Hey everybody, and welcome to Algebra 2 Online. Today I want to talk about graphing two-dimensional inequalities. So these are similar but different from one-dimensional inequalities, which we've talked about, those being the ones that are like on the number line. So if we just start off with this question, so I want you to graph x equals 2 and x less than 2 on separate graphs. We would have, let's do some yellow. So we'll do x equals 2, right, would just be the vertical line through 2. And x less than 2, 2 again. Let's do this right here. So x less than 2 in the xy plane is we're gonna show that with a dotted line because we don't equal it, right? And then to the less than it is things like 1 or 0 or -1 or -2. So we need to shade over here on this half. This would be all the stuff that is less than 2. This is just kind of another question that almost sets the tone for something we're going to talk about next. So pretty soon we're going to start looking at some things in 3D, and it's good to think about what like x equals 2 would look like in 3D. So, if I have in 1D, right, x equals 2, it's literally a point. In 2D, it's a number line, then another number line, and at 2 we just get that vertical line, right? This is my, the green line that I drew above. In 3D, we have a number line, and then we have another number line, and then we have another number line. And this is typically the way we draw it. So this is x, this is the y that but now we have a z. And technically it continues over, right? It kind of back into the page in x, down there in z, and to the left in y. But a lot of times we don't draw that part just for simplicity's sake. So these are kind of just the positive parts of the axis right here. But x equals 2, it's still going to be on the x-axis over there at 2. And now, what this thing looks like is, try my best to draw this thing, but we're going to get a plane, basically. It's going to go down forever, but it just cuts through 2. It's like parallel to the YZ plane in the back, and, this axis is sort of now in front. It's like cut off right there at 2. It's just like a plane. It's we spell it the same way as airplane, but it's the mathematical plane that you learn about in like geometry. So what I really want to talk about today is just graphing these 2D inequalities. So the idea is pretty straightforward. Basically, whatever I give you, you're gonna graph the 2D object just as normal. And the only thing you got to be careful of, this was on that common mistakes assignment, is that if the inequality is a less than or a greater than symbol, you need to use the dotted line because it doesn't equal that object. It's just less than it or greater than it. And then the question becomes the shading part. So if it's a greater than or equal to, you'll just shade above the graph. And if it's less than or equal to, you're going to shade below. So if I have this, right, this is a point slope equation of a line. If I was you, I would always take, the point are those two numbers, and it's always the opposite of them, right? So we have -1, and then +3.5, which is going to put me about right there. -1, 3.5. And then the slope is -2. And so you can just go down to, so down to 1, 2, over 1 will be about right there. So I went, down to over 1. And then I'm going to go down 2 over 1 would put me about there. And so this is the part that a lot of students make a mistake with. You don't want to connect these dots with a solid line because it's a less than. And so it never ever even equals this line. You just need to show that by doing a dotted line like that. And so that's basically number 1 here, kind of done. And then for the shading, it's a less than, so you're below the line. Really the way to do this is you need to check, it's basically saying like what y values, you need to shade the y values that are less than this line that we just drew. So basically we're going to, in a sense, like if you fix a spot, you want to show the y values that are below it. From here, the y values that are below it are straight down, like that. From this spot, the y values that are below are straight down. This one, straight down. This one, straight down. This one, straight down. These are the y values that are below the line. Above the line, I guess the way I just think about it is any point down here, I would have to move up, right, to get to the line. I'm below it. That's what that's what I wrote right here. Shade below for the less than or equal to's. And you can check these problems. So if you want to check, I would just pick something, pick an easy point, like you could pick 0, 0 here. It's a pretty easy one, but we could even pick 2, 1. Maybe I'll do that in a different color. So you can check as many times as you want, but the idea is like if I check 2, 1, I don't want 2, 1 to work, right? So if I plug in 1 minus 3.5, and I check to see is that less than negative 2 times 2 plus 1, hopefully it's not. This is negative 2.5, and this would be, let's see, 3, negative 6. So this is good. It's good that it didn't work because negative 2.5 is not less than negative 6. So this should not be part of the answer. So that's good. You can also check like the 0.00. You could do, if you plug in 0 minus 3.5, it should be less than negative 2 times 0 plus 1, which basically just says negative 3.5 is less than negative 2, which is good. So that means that this point in here actually should be part of the answer. And you could keep checking more points in here. Just don't check things like, negative 0.8 and 0.8. That would be annoying to plug in. Do things that you can kind of do quickly just to check. So I just want to do one more. This one's an absolute value, and I would personally simplify this a little bit so we can use function transformations. So I would move the 8 over. So we get negative y is less than 2, absolute value x plus 6 minus 8. And then I don't want to graph negative y here. I want y instead of negative y. So I'm just going to divide by a negative. I got to flip the inequality. And then everything gets negated. And we would get that. And just as good review, the negative is a vertical flip. 2 is the vertical stretch. 6 is a shift left. And 8 is a shift up. I guess I should also say shift left 6. and the 8 is a shift up 8. And so there's kind of a lot to deal with here. Maybe do it in like pieces, right? So maybe I want to do, I'm going to do negative. So I'm going to get the equation first. I'm not going to worry about the inequality quite yet. I got -2. Let's just do, let's not even do the 2 yet. Let's just do negative absolute value of x plus 6. That's kind of a nice, easier one to start with. So again, we're moving this v graph around, okay? And so if I have plus 6, that's going to move it left 6 over here. And then the negative is going to flip it, so it's going to kind of be down here like that. So I'm going to erase some of this because it's going to get kind of messy. But that blue part would just be that, okay? And then maybe we'll do yellow. So if we do -2 now, x plus 6, the 2 is acting as a vertical stretch. And really what it's just doing is it's changing, the 2 changes the slope of these two parts. So this should have slope 2, and this should have slope -2. So we would get this graph. So you can see that it's gotten, kind of looks skinnier because it's like been vertically stretched, is the idea. And then last but not least, let's maybe just do like purple. If I do the plus 8, I would just move this yellow graph up 8. And so it would end up, its peak would be right about there. And then we would have that same slope of 2 or -2. And so that would be my final graph down here. But I want it to be a greater than. And so I'm going to need to make make it dotted like that. And being greater than means that we would shade above the graph. So, at any point on the graph, I need to go above. At any point, I go above. Any point, I go above, above. I would just get this right here as like my final answer, and that's gonna, that could continue, and you would get all of that. And you could check it. I don't think I'm gonna go through the check this second, but checking like 0, 0 here should work because it would be in the shaded area. And that is about it for graphing inequalities.